Hello everyone, welcome to the channel General Intelligence Hub. Today we are going to the first video of our machine learning foundations, in which we are going to explore different statistical metrics. Before we train any machine learning model, we need to understand one thing. Data is not just numbers, data also has shape. So let's go through the video. Here we have a series of numbers which are 10, 16, 8, 5, 20 and 20. If someone asks you to calculate mean for this, it would simply be addition of all this, and we divide it with the number of elements in the series, which are 6. And if someone asks us to calculate the median of this series, we can do a simple thing here. We can sort this entire series. So this is after sorting this series and basically writing it in ascending order, and we find the midpoint of the series. As the series now has an even number, we take an average of these two elements. So median is the mid value after sorting. And mode is simply the most repetitive number in the series, which is 20 here, so mode is simply 20. So this is how we calculate these basic statistics, and we have learned all this in school and our fundamentals as well. Now let's look at the distribution plot. So in machine learning, we always deal with number of distribution plots. So distribution plots helps us understand what kind of a data it is and what kind of a model do we use, whether the features perfectly model the data, and all these questions. So distribution plot simply starts with plotting the frequency of individual numbers in the series. So here 0 let me remove 0 from here. So we don't have any zeros in the plot, so the frequency of 0 is 0 itself. And for 10 we have 2, and for 20 we have 3, and for 30 it's just 1, and for 50 it's again 1. So if we start drawing the plot, and also consider we also have 60 in our series, but we don't really have it in the series, but as a labeling point we do. So that will go like this. So this is a distribution plot. Now from the frequency analysis itself, we got a distribution of this entire data that we have. So what now we have understood what this distribution plot is. Let's try to locate mean, median and mode on this distribution plot. Yeah, so first things first. So whenever we are asked to locate the mean, median and mode in these kind of distribution plots, right? So the first easiest thing is to plot the point the mode, which is the most repeated element in this series, and in this case it's 20. So simply 20 is the mode. And the second thing for median is, so the median is something that divides this entire distribution into two halves which has equal area. So where do I cut this distribution so that the left part and the right part will have equal area? It will be somewhere around here. So if I cut that there, like this half and this half would tend to have equal area. And also from our calculation, so if we try to find the median of this, it will be around 20. And so yeah, around 20 itself is the median as well. and 20 is the mode. So if we cut it here, it's going to divide this entire region into two halves of equal area. And the mean is a little bit tricky. It's like the mean is the balance point of this entire distribution. So it's like the center of gravity. So where do you think we should place our finger so that we can balance this entire distribution on a single finger? So that will be somewhere around here. Also, if we calculate the mean of this entire series, so that would give us around 22, and which is again near 20. So if we place our finger somewhere here, then this whole distribution is going to be balanced. So that's basically the balance point. So now we have understood what mean, median, and mode are, and how a distribution plot actually works, and how we can locate mean, median, and mode on a distribution plot. And let's go through different kinds of distribution plots right now to understand the data. So the first thing is the symmetric distribution plot. Again, in this plot, the mode is really simple. So this is our mode, and in a symmetric distribution plot, all mean, median, and mode tend to lie around the center itself. So here itself we'll get to see the median and mode if it's a perfect symmetric distribution. So mean, median, and mode all are near the center. So yeah, because if we in a symmetric distribution plot, we can balance this from the center, and the mode is the highest frequency data point, and that's also at the center. And we can divide this entire area into two equal area halves from this point itself. So that's the median. And in a left skewed distribution plot, so the easiest thing is to mark the mode first. So this will be our mode because it corresponds to the highest frequency point. And where do you think we should cut in order to get an equal area? So that will be somewhere around here, because then we'll get this area and this area as equal halves. And to balance this, we should move the finger a little bit towards the left. So this will be our mean, and this will be our median, and this is our mode. So in a left skewed distribution, we get to see mean is less than mode is less than median is less than mode. And similarly, you can try it as an exercise to locate the mean, median, and mode on a right skewed distribution plot. We don't have to remember these as conditions, but like just from the distribution itself, we'll be able to relate and reason why this happens. So how does it all relates to ML, right? So yeah, let's consider a classic machine learning problem, which is house price prediction problem. And we have a set of data points to predict the house price here, which are house size, bedrooms, and the location and the age of house, and our goal is to predict the price of the house. So consider we have a right skewed distribution. Here most houses are around 200 to 500k, because here is where all your data is mostly concentrated. And a few luxury houses have 5 million to 20 million as their price. So how does this data skewness affects our modeling capability? Okay, if we see the features here, they don't have an element called luxury in it, right? So our data would typically have values like this. It's a 3-bedroom house, and it's a good location, and the house price is 700k. And there is another data point in the data set. It's a 3-bedroom house and it's also a good location, but the price is $3 million because this house has a ocean view. Obviously the houses which are near the ocean will have like much more price, right? But this ocean view isn't getting captured in our data, which is the luxury factor. So then what happens is that our model looks at these 2 points and then thinks for a 3-bedroom and a good location house, the price will be around 1.5 million. It's trying to bias its opinion because it has seen higher prices for the same set of attributes we provided. So this data skewness will try to pull off the price to a higher level, and it will not model the data accurately. So this is why we have to check for data skewness and also select the right model before, and also select the right set of features as well before going on to the actual modeling step. So the final takeaway from this video is to the mode is the peak of the frequency, and median is the 50% area split, and mean is the balance point. And distribution shapes decide where they appear, and ML models learn from that same distribution itself. So if you like this video, just drop a like, and I'll be sharing this notes PDF as well in the description, and support the channel, and we'll be covering an entire playlist on machine learning with in-depth analytics like this. It will all be really analytical and intuition driven rather than remembering stuff. So yeah, thank you.